Hello and welcome to our course Visualization of Proteomics Data using R. This course is supported by DENBI, the German network for bioinformatics infrastructure, and Elixir Germany. In this course, we will give an introduction to the ggplot2r package for data visualization, and then the exercises we will show possible applications for quantitative proteomics data. So here on the right, we can see the topics that we will cover today. So we start with some basics and data preparation. For example, ggplot2 requires the long data format, and we will show you how you can transform your data into that. We will look into factors and in general how you can manipulate your data with the dplyr package. And after that, we will look at different plot types you can do with ggplot2. And then we will look at the customization, so which elements of the plots you can customize to your needs. For example, scales, labels, the coordinate system, legends and themes, and how you can combine plots. And then in the end, we will do a case study where we will have a volcano plot with different elements that we will build up from all these things you will learn until that. So in the first part, we will look into the very basics of ggplot2 and how to process the data using different packages from the tidyverse. So some basic information on the ggplot2 package. So the GG stands for Grammar of Graphics, and it has a comprehensive functionality to create all kinds of plots and visualization. It has quite some different syntax compared to base R graphics, and you can simply install it from the CRAN repository. So ggplot2 is part of the tidyverse, which is a collection of R packages for data science, and they share an underlying design philosophy, grammar, and data structures. And you can see here that while installing tidyverse, you're actually installing 9 different packages, which are listed here. And we will focus on ggplot2 in this course, but we will also need some of the others to prepare our data for ggplot2. This course here is not about the tidyverse, but about data visualization with ggplot2. And in general, it's possible to use ggplot2 without using the rest of the tidyverse. But we will show you also some handy functions from the tidyverse for data preparation. If you want to know more about the tidyverse, there are different possibilities. On the website, for example, tidyverse.org, you can find a lot of cheat sheets, documentation, and information on further packages that are related to the tidyverse, and also the R for Data Science book, which is really available on this website here, is based on the tidyverse. In this course, as I said, in the exercises, we will work with proteomics data, but here for the smaller examples during the lecture part, we will use 2 other data sets. The one data set is the IRIS data set, which has measurements on 150 iris flowers from 3 different species. You can see here Setosa, versicolor, and virginica. And it's quite handy because it's directly available in base R, so you can just type in iris in your R console and you will get this data set. The question now is, why should we use ggplot2 for graphics? And here's a small example. I used here the iris data set, which has here the length and the width of the sepal flower parts. And I will just plot here a scatter plot with the ggplot2 package. You can see that I only need some few lines of code, and I get a really nice looking plot with a legend, with different colors for each species, and so on. Now we can have a look what happens if we recreate this plot in base R. So we start with the basic scatter plot, then we increase the font size, we increase the size of the dots, we also change the shape from a circle to a solid dot, we change the axis labels because before you always had this iris dollar before that, which is not that pretty. And then we add some colors, which is a bit more complicated in base R, because you have to create a vector of the colors with the 150 elements. So for each data point, you have to define which color it has. And then, yeah, for the legend, it's not done automatically. It's basically, yeah, you have to do it manually, which, yeah, adds even more code, but on the same time, it's quite error prone. So when you compare ggplot2 over base R graphics, you will see that ggplot2 does many things right automatically, but the plots still remain highly customizable at the same time, which we will see at the end of this course. For example, legends are created automatically. In base R, you have to do it manually, and this is quite error prone. You also have nicer default colors, and coloring data points by a certain column, for example, is really easy. You also have a more intuitive naming of arguments. For example, in ggplot2, if you want to change the shape of dots, it's called shape. And while it's called PCH in base R, also, for example, if you want to change the size, it's called size and not CX. For example, for color, you can use the British or the American spelling, while in base R graphics it's just called col. You have a default grid in the background. That's not that easy to do in base R, and you also have a really consistent look between different graph types. Now we will have a more deeper look into the basic syntax of ggplot2. So first you load the package, and then always you start your plot with the ggplot function. In this function, you can, for example, define which dataset you want to use, in this case, iris. And then a so-called mapping follows. In this mapping, with the AES function, you can define the so-called aesthetics. So basically, which column in your dataset is used for which part of the plot. So here in this case, for the x-axis, we want to use the sepal length. For the y-axis, the sepal width. And for color, we want to use the species. And this basically defines which data you want to use and which column you want to use for what. After that, you define which plot type you want to do. For example, here we add this geom point for a scatter plot. So there are different geom functions for different kinds of plot. And inside this geom function, you can also define and change some of the aesthetics. For example, here I set the size to 0.5 for the dots. And then you can add other things, for example, the theme. This is the overall appearance of the plot. And as you can see, these elements of the plots are simply added with a plus sign. Here are two examples where I just want to show you the difference. So defining the data and the mapping is also possible within the geom functions here. You can do this. This comes in handy if you want to combine different plot types, for example, with different parts of a data set or something like this. One important thing is if you define aesthetics like here within this AES function, it always refers to a column in the data set. So for example, X is the sepal length, and sepal length is a column in the iris data set. If you define it outside of this AES, it's taken as a fixed value. For example, here the size is set to the value 0.5. It's not interpreted as a column or something, it's simply set to a certain value. This is especially important if, for example, this 0.5 would be assigned to a variable before, like for example, point size or something like this. Then you set it here, and this is important to know that it's like the value is taken literally and not as some kind of column of a data set. Here's a table of some common aesthetics that you can use in different kinds of plots. We already saw X, Y for the X and Y axis. This can be discrete or continuous depending on the plot type. You have the color, which is colors of points and lines. Can have them also discrete or continuous. We will see this on the third part of the course. Fill is also color, but for areas. For example, if you have bar plots or box plots, it's the area inside these plots that is colored. You have the shape and size for data points. You have line width and line type for lines. Alpha is the level of transparency, which makes sense, for example, in scatter plots to make them transparent if you have overplotting a lot. And a group is for line plots to determine which points are connected in a line. Data preparation is very important when you work with ggplot2 because here many things cannot really be solved by changing the code of the plot, but by adapting the data to what you want to do. So some examples here. The data has to be present in long format. We will come to this in a second. ggplot2 also makes use of factors for everything that is a categorical data, for example. And there are many handy functions from the tidyverse that we will show you. For example, filtering the data, mutating the data, grouping the data, summarizing the data, and so on. We will start with wide versus long format. So you can see here a classical data set in the wide format. We have here one column with the protein accession, and then we have following columns with patients and controls, and the entries here in this table are the protein intensities, for example. On the other hand, here we will have the long format. So we have here also an accession column, but you see that each protein accession here is there multiple times, because then we have a sample column where each sample is written down, and then there is only one single value column here. So basically, this line here corresponds to the information done in this cell of the table here. So you see that actually this information here may be quite of redundant. It may be longer. It may take more space to save it, but it's the data format that ggplot needs to easily choose columns for example, coloring or other aesthetics. So you have always to think about how to transform your data into this long format. Okay, so we will look now into how you can transform your data from the wide to the long format. Here I have a wide format for the iris data set. You can see that I added an ID column. This is just for being able to transform it back later. And what you can do is use the pivot longer function from the tidyr package. You give it the data set, you specify which columns you want to use to transform into the long format, in this case the second column to the fifth column, so everything with numbers. And then you have to specify how to call the two newly created columns. In this case here, names2 defines the column name of here these column names, and values2 refers to the column name which will receive all these numbers here in the table. And this is the outcome here. You see that you have here the ID column and the species column, then the column with the variables and the value. This first line here, for example, in the original data set is now 4 lines in this long format. You can also transform back. So this was the result from the slide before. And then you can use the pivot wider function, give it a data set in a long format, and then again you can define which column should be transformed to column names in the wide format and which column will be transformed to values in the wide format. And this were these two columns here, variable and value. And you can also or have to define ID columns. So basically give the function an idea which of these elements here belong together. So this is why I added this ID column here before, because this is the only way to know that these 4 rows actually belong together to a single observation. And this is then again the result. So it basically looks like the original data before. One thing to keep in mind that actually the definition of what is wide and what is long format is flexible a bit, because it depends on the plot you want to do. What we saw in the example before is that we used actually the original wide format iris data set to plot a scatter plot. So this actually was long enough to do this because we wanted to use the sepal length on the x-axis and the sepal width on the y-axis. So because we wanted to use these two existing columns, we didn't have to transform it into a longer format actually. But if you want to do, for example, some kind of box plots of the 4 variables next to each other, so 4 box plots next to each other, you would need actually the variable column in this long format as the x-axis and the value column as the y-axis. So for box plots, you definitely need to do something and to transform it into the long format. So the message is you always have to think about which kind of plot you want to do, which columns you would need to map to the aesthetics, and then according to that decide in which kind of long format you can or have to bring your data before starting to plot. In some cases, you want to add some additional information into your data set. So this is here actually the long format iris data set. And you can see that in the variable column, you actually have 2 information encoded. You have the kind of leaf on the flower, so sepal or petal, and you have which measurement was taken, the length and the width. And in some cases, you want to, for example, separate this information and have it in 2 different columns. And for that, there's a function in the tidyr package called separate wider the limb. So basically, you give it again this data set, you define a certain column you want to change, which is the variable column here. It's the limiter of the 2 information parts is a dot. Then you give the function 2 names for the 2 new columns it should create it, and then you can decide if it should remove the original column, for example. So here in this case, you can see the result that it now separated the part of the flower and the measure, but still keeps this original variable here. Because here in this data set, we had this information of flower part and measure in one column, but want to separate it to maybe use it later in some plot. The second option is if you have an additional data set. So for example, here you have again a long format data, protein accession, different samples and different protein intensities, and you have next to that a second data set where you have, for example, the age of the patient that you want to use in some plots, for example, to color code this. And what you can use then is to use the match function. This is from base R. So you basically match the sample column of this data set and this info data set. And then you can grab the age from the info data set. So basically you can see the result here that each line here now gets the corresponding age depending on this sample value, and then it looks it up basically here and sees that patient 1 was 31 years old, and so each row that depends on patient 1 will get an age value here of 31. So as I already indicated, ggplot2 uses factors. This is a data type for representing categorical variables. So internally, these categories are represented by integer values, but they are assigned to levels, so names that are displayed instead of these integers. For example, here you have just a vector of characters B, A, and C, and then you transform it into the factor with the factor function, and then you can see, for example, levels of Y, you will get ABC. If you, for example, remove the fourth element here, which is the only occurrence of C in this factor, then you will see that the factor is only BAABB, but the levels still know that potentially the category C exists. If you don't want to have that and want to delete empty levels, you can use the drop levels function on this factor, and then you will see that this C level disappears. The problem with factors is that if you don't specify, then the factor levels will be in the alphabetical order, which is sometimes not how you want to have it, especially because ggplot2 will use this level ordering for ordering things in graphs. For example, for shapes, for colors, for ordering box plots on the x-axis, and so on. So it may be required to reorder the levels. Here's an example. Imagine you have some kind of scale with low, middle, and high. This would be also the preferred order, of course, but alphabetically, it will be ordered to high, low, middle. You can change the order, for example, by just applying the factor function again, and then with the levels argument, set the order you want to have, like low, middle, high, and then you will see that this low, middle, high is now appearing here in this level order. What is also possible is that if you want to change the labels, for example, you see that you don't have so much space in your plot and want to shorten it to L, M, and H, for example, you can do this by using the labels argument here. And I also want to point out the forcats package, which is part of the tidyverse. This has some really handy function for reordering levels. For example, reversing the order or ordering it in order of frequency of levels in a certain data set and so on. So just have a look, and there's also a cheat sheet on that. Next to the IRIS data set, in the following exercises, we will also use the Gapminder data set, which contains socioeconomical data from 142 countries. There is a package, Gapminder, which contains this data set, and you will have data on the life expectancy, population, and GDP per capita for different years from 1952 to 2007. And now it's time for the first part of the exercises, so please have a look at the exercises 1.1 and 1.2.